Hey guys, we're going to work on 10-4 chart notes. I'll try to write large so that you can see it. If you don't understand, please come in. Okay, an inscribed angle. First, let's talk about the only other kind of angle we've known with circles right now. That's a central angle. A central angle. There's a couple key things. Vertex on center. And the second thing is the measure of a central angle is the same as the measure of its arc. Okay? So we've got a central angle, vertex on the center, angle ABC is a central angle. The measure of the angle is the same as the arc. If the arc is 40 degrees, the angle is 40 degrees. Always the same. An inscribed angle is an angle that has the vertex on the circle. So angle ABC is an inscribed angle, and it has to be inside the circle. So the sides are chords, okay? So vertex on the circle and the sides of the angles, okay, are chords. So inside the circle, vertex on the circle, the sides are chords. Okay, I'm going to come back to this in a second. But this arc right here, ignore this line, it's just there to be tricky. This arc is the intercepted arc of angle ABC. This arc corresponds to the inscribed angle ABC. Okay, we're going to talk about intercepted arc. It's the arc. Remember, arc is just a piece of the circle. That's all it is. Okay, so if I took my hula hoop that I have in the classroom, I cut a piece of that, that is the arc. So an arc that lies between two lines or segments or rays. Okay, that's intercepted. It's like right here, I've got a ray sticking out, that side of the angle, that ray sticking out. So where the ray shoots out of the circle, this is the intercepted arc. Arc AC is the intercepted arc. Okay? We name it, remember, it's a minor arc, so it's going to be to start and end, right, with the arc curve on it. Okay, this is big dog here. The measure of an inscribed angle. Measure of inscribed angle equals 1/2 of its intercepted arc. It's always 1/2 of the arc. Write that and think for a second. So on this, a central angle, arc, and angle are the same. Central angle, vertex at center, and the measure equals the arc measure. On an inscribed angle, this inscribed angle here is 1/2 of its intercepted arc. So on this one, the arc is 40, the angle is 40. On this one, let's say the arc is 100, so the angle would be 50. So when we write this, we could say the measure of the angle is equal to the arc divided by 2, right? the measure of the arc is equal to the measure of the angle times 2. So let's take this right here and write it up here also, right? I said all the key things. Vertex is on the circle. The sides of the angle are chords. Really, they contain chords because they can keep going. And the measure equals the arc divided by 2. Okay, 1/2 of the arc you're dividing by 2. Okay, now let's watch this one here. I'm going to show you real quick. I've got 2 different inscribed angles. The vertex of angle ADB, right, is D, so it's on the circle, and I've got its arc right here. Okay, let's say this arc is 100 degrees. If the arc, the measure of the arc AB equals 100, then that would mean the measure of angle D equals, here's D, it shoots out there, this is inscribed, the arc divided by 2 is 50. Now let's look at another angle that shoots out, has the same intercepted arc. Can you all see it? In this picture, I also have this angle C here, okay? If you look, angle C has the same intercepted arc. They both have the same arc, intercepted arc, AB. So we said angle D is 50, angle C is also 50. Okay, both of those angles are 50 degrees. So let's write this, okay? If 2 inscribed angles have the same intercepted arc, then the 2 angles are congruent. Okay, if they shoot out to the same place, they're congruent. This one you could figure out, you don't really have to memorize. But you have to, huge, you have to know what an inscribed angle is, and you have to know the 3 things about it, right, to recognize it. You have to know the measure is the arc divided by 2, and the arc is the measure of the angle times 2, okay? So that's both of these together. This one you could figure out, you don't have to necessarily memorize. These are vocab here. This is so that we could talk about stuff. Let's put a pentagon in here. So stick 5 points. They don't have to be evenly spaced. Do however you want. So we're going to put 5 points on the circle. Let's connect them. 1, 2, 3, 4, 5. Okay, we just drew a pentagon, and we say the pentagon is inscribed within the circle because each vertex is on the circle. Okay? So when we do this, this comes with the definition, but I'm going to write it anyways. Inscribed polygon. The polygon is inside the circle. Okay? And each vertex of the polygon is on the circle. So in this, let's write a sentence to help us with the understanding, okay? A polygon, poly just means many, so this is many sides. So it'd have to have at least 3 sides, right? A triangle is a polygon. A square would be a polygon. We could call it a quadrilateral, right? Any polygon. So we're going to say polygon. We don't have to write the word. We could just put the letters. A, B, C, D, E is inscribed within circle. We got to give it a name here. Let's call it circle T. Within circle T. Okay? That's it. Just know what inscribed means. It means inside, and each vertex is on the circle. Circum means to go around. Scribe means to write. So it's the circle that you write around something. You guys can think of words with circum. Circumvent, circumstances, circumnavigate. It's all to go around. Okay, and a scribe is just a person who writes. So on this one, this is the circle that contains the inscribed polygon. Okay? So we could say it's the circle, let's kind of make it generic, the circle that goes around the inscribed circle, polygon. So remember, by saying that, that means each vertex is on it. Let's put a triangle in here. So put 3. You don't have to make it equilateral. Put it however you want. 3 points on here. We'll call this triangle cat. Okay. And let's put, I don't know, kind of looks like it could be right there, right? S. Okay. Circle S circumscribes triangle cat, C-A-T. Okay? Remember, each vertex of cat has to be on the circle. So those are just words. I don't ask you to define the word, but you have to know how to apply it. Now this one's kind of cool. Okay, we're going to put this one, you could figure out. This one you have to memorize. This one you can figure out, but you got to think. Okay. Let's talk about some stuff that you know real quick, okay? Let's do just over here, right? A full circle is 360 degrees, right? Oops, sorry guys. This is just a real quick review. A full circle is 360 degrees, right? A half circle, which you're going to know by the diameter, right? A half circle is a semicircle. I can't fit it all. And it equals 180 degrees. Okay, so think about that, and then we're going to come back up here. Okay, so I've got angle B. Here's angle B. Now notice that you have this diameter. So we just said a diameter divides a circle into 2 semicircles, right? Okay, so this is 180 degrees. Okay, that semicircle is 180. Now we have angle B. Angle B is shooting out at the end points of the diameter. The diameter is AC. So the intercepted arc of angle B is the semicircle. The vertex of angle B is on the circle. The sides of the angle are chords. Okay, so this is called an inscribed angle. From what we learned, the measure of this inscribed angle is equal to its arc divided by 2. 180 divided by 2 equals 90. So measure of angle B equals 90 degrees. So whenever you have a right, so this means angle B is a right angle, and triangle ABC is a right triangle. Okay? Anytime a right triangle is inscribed in a circle, the hypotenuse will always be the diameter. Okay? So let's write that. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Okay? That you can look at though and figure it out. Okay. This, you could go both ways. We talked about the converse also being true, and this is a biconditional statement. That's all I'm going to write. I'm not going to explain that now. I could explain in class if you want to ask me. Okay, now this one is harder to figure out, so I'm just going to tell you, okay? I explained it why to the students in class with you guys. I'm just going to tell you what is true. I have a quadrilateral inscribed within circle C. Opposite angles, and when I'm talking about opposite angles, I'm not talking about angles across this way. I'm talking boxing ring opposite angles. Those are boxing ring opposite angles. So when we're doing this, I want you to think about a boxing ring. So on the diagonal, okay? Whenever you have, and it's only true for quadrilaterals, and if the quadrilateral is inscribed within a circle, okay? So I'm going to write this as a biconditional statement. A quadrilateral can be inscribed in a circle. Okay, this if and only if statement. Okay, this is what I'm talking about here. It's a biconditional statement. I'll explain. If and only if the opposite angles are supplementary. Okay. So what it's saying, if the opposite angles are supplementary, then the quadrilateral is inscribed, okay? If the quadrilateral is inscribed in the circle, then the opposite angles are supplementary. Supplementary means the sum equals 180. That's what supplementary means. So all we're saying is the boxing ring opposite angles, when you add the angles together, it equals 180, okay? Opposite angle plus opposite angle equal 180 when the quadrilateral is inscribed within the circle. So I could also look at opposite angles here. These are boxing ring opposite angles. They're on the diagonal. So those two angles also add to equal 180. Okay, that's it for the work. When you're looking at these, look, is the vertex at the center or is it on the circle? This one, it's on the circle. That means this is inscribed. So the angle G, the measure of angle G is half of its arc. Okay, this one says how much is arc TV. Notice again, this comes from an inscribed angle. It's the intercepted arc of angle U. Angle U is inscribed, so the arc is twice as much as the angle. On this one, it says how much is the measure of angle X. Well, here's the measure of angle Y. Here's its intercepted arc, so the angle times 2, right? 72 times 2 is 144. Now, what's the measure of angle X? Measure of angle X, it has the same intercepted arc. So what is that angle going to be? Okay, I think most of these are okay to look at. If you have questions, please come in and ask. And I hope this is helpful for you guys. Have a good day.